Hey, welcome to day 5 in Algebra. We are talking about inequalities. An inequality is like something that's not equal. So we have greater than symbols, less than or equal to, greater than or equal to. In elementary school, we kind of talk about this being like the alligator mouth, each the bigger one. When we talk about this in Algebra 1, we always refer to reading it as a sign from the x. So like if I was going to read something like this would be x is greater than 4. So if I want to graph that, say on this first line, if you have this one doesn't have a 4. So let's choose one that it does have. Let's say x is greater than 0. If you're going to do that, you would go to the number 0. And we're going to talk about how do I know if it's an open circle or a closed circle and which way do I shade. So I'm going to put next to this, if it does not have a line under it, it's not equal to something, we're going to use an open circle on that exact number. Okay? If it has a line under it, like the word equal to, then you're going to put a closed circle on that number. Alright? So the number 0, greater than 0, I'm going to put an open circle where a point would be at 0, and greater than, you have to look, well, the numbers 1, 2, 3, these numbers are greater. Some people shade lines like that. Some people draw an arrow from that point in that direction, pointing that way, but it should extend to the end of the line. Let's say this one I say x is less than negative 2. Then on that one, you would go to negative 2, we'll put an open circle, and less than means shade to numbers smaller than that. So I'm going to shade to the left. Less than or equal to, less than or equal to, say it's less than or equal to, it has the line under it. This time the only difference between these two is this one has a line under it, just signifies equal to. Equal to means it's a solid in point. If something's equal to it, it's filled in. And still less than is left. And this works because x, you're reading from the x value. So let's say this one I say x is greater than or equal to negative 2. That's the case, it's still equal, so I'm going to put equals negative 2. But greater than, these numbers to the right are greater than negative 2. So some real life situations, when would you have this kind of a saying? Like in a budget. If I have a $500 budget for a party I'm throwing, I would want to spend less than or equal to $500. I don't want to go over $500 because that's all the money I've reserved for that party, or that would be within my budget. If I need to make a profit on something, I need to sell at least 50 of something, then I would want to say, I would want x is greater than or equal to 50. If I need to sell 50 t-shirts in order to start making a profit for my business, then I would want x is greater than or equal to 50, or greater than 50. So those are just some real life, when would you use an inequality? Alright, in those shadings, the shaded part represents the x value. So these are numbers that are greater than negative 2. This is the x. These are numbers that are less than negative 2. All of those are represented there. Solving inequalities. You just solve it like an equation. The only difference is when you multiply or divide. By a negative number, the inequality sign flips. That means if it's a less than sign, it then flips to a greater than sign. And if it's equal to, like less than or equal to, it flips to greater than or equal to. It's only when you multiply or divide by a negative number, then the inequality, this is an inequality sign, will flip. Okay. So, this activity that it's referring to is just practice looking at a picture. Like, we'll just do two here together. For instance, this has an open circle, and the shading is going to the right. So if I was going to try and figure out, okay, what do you think we would call that? Is that, remember x is the shading are we going to say that that is x? You always start with the variable. We'll just call the shading part x. Are these numbers getting bigger or smaller from -1? Because -1 is where the circle is. Since they are getting bigger, we'll say it's greater than. Okay? I didn't put the line under it because it's not solid. It's not equal to. Let's look at the next one. We have x and the dot is on -2. So you have to decide, is the direction it's going, are these numbers getting bigger or smaller than -2? If you go this direction, these numbers are getting smaller, and I'm going to say this is less than or equal to because this one has the solid dot on it. When it's a solid dot, you put the equal to line. Okay, let's try some solving with inequalities. First one we have is a one-step inequality. We solve it like an equation to start with. So if it's +4, we're going to -4 to both sides. And instead of bringing down an equal sign, you're going to bring down the inequality sign. So 1 minus 4 is -3. So on our number line here, we're going to find -3. This one doesn't have the line under it, so we're going to put an open circle at -3. This symbol is less than. So we're looking at numbers less than -3, which would be going to the left. Okay, this one, you start on the side with the variable, so the opposite of -5 is 2 plus 5. -3 plus 5 is 2. Again, bring down your symbol, not an equal sign. And if you always read from the side of the variable, we could say 2 is less than or equal to y, but it's easier if we read it from the direction of the variable. So if you read from the y, I would write this out as y is greater than, because it's on the, like I said, the open side of the alligator's mouth kind of thing. Y is greater than or equal to 2. So again, if you read from the letter, you can also rewrite this to look like y and have the big side still pointing towards the y. So if that helps you graph these. It does have the line under it, so on the 2 we're going to put a closed circle, and numbers are bigger than 2 would be 3. So even if you tried it up here, does it make sense? 2 is less than or equal to 3. Try a number. Is 3 work there? Is 2 less than 3? Yes, so I know I shaded the right direction. Okay. This line in math means divide. Opposite of dividing by 2 would be 2 times 2 to the other side. Okay, n is less than or equal to -6. You'll notice on this one I kept the sign exactly the same because the number you're multiplying by is a +2. If you multiply by a positive number, it doesn't change the inequality sign. So if it has the line under it, that's a closed circle, shaded in, and n is less than. So we're looking for numbers smaller, that's why it's a little side, than the -6. This last one here, we're going to divide by -8. So we have x, but here's the thing, when you divide by a negative number or multiply by a negative number, it's going to flip the inequality sign because we divide it by a negative. So my symbol is going to flip the direction, and -8 divided by -8 is +1. So no line under there. You do an open circle, and numbers less than 1 would be 0, negatives, all the way down. All those numbers represent numbers less than 1. Alright, hopefully graphing you're kind of getting the hang of. It has a line under it, it's a closed circle, no line is open circle. Let's just do some practicing solving. Really, we're just working on solving equations again. The only difference is at the end, if you divide or multiply by a negative, it flips the inequality. So this is a two-step equation. We're going to move the one that doesn't have the variable. Bring down your 5x. bring down the inequality sign. That's a big mistake I see. People want to bring down an equal sign, but there's no equal sign in this problem. Okay? So then, this means multiply. The opposite is to divide. 10 divided by 5 is 2. I did not change any inequality signs because I was not dividing by a negative. Okay, the next one. Moving the number 8, opposite of plus 8 to minus 8. Two minus 8 is negative 6. In this case, I have to divide by a negative number. So when we divide by a negative number, it's going to flip this inequality sign. And negative 6 divided by negative 6 is 1. So again, we flip the inequality when you divide by negative. Okay. Next one, we're going to subtract 3 to the other side. We have 2/5 y greater than 2. You can do this in one step if you just want to then divide both sides by 2/5. I always kind of do it in two steps because I don't like fractions. So opposite of divide by 5, I'm going to times by the 5 to the other side. You get 2y is greater than 10. And then I'm going to divide by the 2. So y is greater than 5. I did not flip anything because I was dividing by a positive number there. Even if way back here you divide by 2/5, when you divide by 2/5, you're still dividing by a positive number. Alright, next one is still more solving, just practicing a little bit bigger. When you have variables on both sides, we want to move our variables to one side. This one is a special case though, because if you notice, the x's cancel out. So I have negative 2 is greater than negative 2. Well, can a number be greater than itself? The answer would be no. So it's no solution. If it had said negative 2 is greater than or equal to, like the little line on it, then yes. That would be called infinite solutions. But the way it is right now, it's not equal to each other, or not greater than they're not greater than each other, so it's no solution. When you have a parenthesis in a problem, remember you want to distribute. Distribute means multiply. So negative times a negative makes positive 6. Once you have your parentheses gone, you want to get all your numbers on one side, all your variables on one side. So we'll subtract the 1n to this side, gives us negative 4n. Okay, then we'll subtract the 6 to the other side. Notice on this one, I put my numbers on the left because that's how I like to graph. But on this one, we're going to end up dividing by a negative. And so hopefully you've picked up when you divide by a negative, you have to flip the inequality sign. I'll put a little note here. I flip the inequality sign when I divide it by a negative. Alright, the next ones are called compound inequalities. It's when you want your numbers to be between two things. So x is greater than 2, and x is less than 2. So 2, it's bigger than 2, and it's less than 6. The numbers between 2 and 6 would be what you're looking for. So one way they write that, if you look right here, they put inequality signs on either side to say 2 is less than x, which is less than 6. So they show that with open circles on 2 and 6, because there's no lines under them. And x is between those two numbers, so you shade between them. On this one, it says 2 is less than or equal to. So you'll notice on this one, they have the closed circles versus the open circles on that one. An OR problem typically looks like it goes in one direction or it goes in the other direction. So x is less than 2 here, or x is greater than 6 there. So the difference between these two have the line under it, so those are equal to. Whereas this doesn't have the line under it, so those are the open circles. Alright, last example here, we have an OR question. In OR problem, we work out the two problems individually. So let's focus on the left problem first. So I'm just going to draw a wall here, so I can do all my work for this equation over, or inequality over here, and I'll do all this on this side. So opposite of plus 5 is to minus 5. Okay, now we're ready to divide. Divide by 8. Divide by 8. 8 divided by 8 is 1. You notice I didn't flip anything because I wasn't dividing by a negative. So let's try this problem now. 2r minus 8. Well, the opposite of minus 8 would be 2 plus 8. Okay, now we're ready to divide. Again, I'm dividing by a positive 2, so I'm not going to flip anything. 10 divided by 2 is 5. So you only flip if you're dividing by that negative. So let's graph this now. It says from 1, you see the little line under it, so on 1 we're going to put a closed circle, and this is a less than. So these are the numbers less than 1. On 5, there's no line, so I'm going to put an open circle on 5, and we want numbers greater than 5. So greater than goes to the right. These are all numbers bigger than 5. So that's how kind of typically an OR problem looks. The next one, you can see this is squished together. That means X is in the middle. Or in this case, V is in the middle. So when you're doing this, you typically, I'm going to highlight the middle. These are between the two inequality signs. You want to start in the middle and work your way to the outside. Just how, like here, we added 8 to the other side. Here, if we have minus 6, we want to plus 6. The problem is we have two equal signs on this one. So instead of just plussing 6 to this side, you also have to plus 6 to that side, because these represent two inequality signs. Okay? So negative 27 plus 6 is negative 21. We'll bring down our symbol. Then, still working from the middle, I'm going to divide by 3 on both sides. So I get negative 7. I'm not going to flip anything. I was not dividing by a negative number. So on this chart, it goes by 2's. So negative 7 is going to be located between negative 6 and negative 8. So I'm going to put a point between those two things, and that's going to represent my negative 7. Okay? 10 is already on here. I'm putting solid circles on these because you can see there's lines underneath these. The V is all the numbers from negative 7 to 10. So I'm going to show you every number, all those solutions between negative 7 and 10. Okay? So that's called a compound inequality. Open circle for less than or greater than, closed circle if it has the equal to, like a line under it. So this is a closed circle, this is an open circle.